right, I'm going to start talking about the sort of second to last broad topic, first one after the second exam. This one is about complex experimental designs, so I'm going to be walking through some different examples, talking about some new concepts related to how you look at multiple variables at once. Quick programming note, if I sound a little bit different, it might be because I was playing with my daughter today and we kind of bumped heads. So her forehead hit me in the mouth and I kind of cut the inside of my upper lip. So still kind of getting used to this slightly swollen lip. Not the best circumstances to record, I guess, but if you're wondering, that's what it is. And maybe you can't notice. Maybe I shouldn't have said anything in the first place, but anyway, very distracting to me, maybe not so important to you. All right, so complex experimental designs. Some of these concepts are things that I have been alluding to a bit over the course of the class, how frequently you're not just going to be using one independent variable, one dependent variable. A lot of studies are more complicated than that, but for purposes of demonstrating many of the concepts that we've talked about so far, I've used relatively simple examples. So we're going to start talking about slightly more complicated designs here. And when you use the terminology to describe complex experimental designs, that can have a few different meanings. It basically could mean any study where you have more than one independent variable, so more than one thing that you are manipulating or that you're hypothesizing is causing some change in something else. Or it could be that you have more than one dependent variable, that you're measuring you're measuring more than one dependent variable, meaning it's not just different operationalizations, like you're not looking at stress in two different ways. Maybe you're looking at stress and health outcomes or something like that. And of course, you could have both of these things. You have more than one independent variable and more than one dependent variable. So these all kind of qualify as complex experimental designs. But for the most part, what people mean when they talk about this is more than one independent variable. And that's what I'm going to be focusing on in the examples that I have here today. So for our purposes, complex experimental designs, for the most part, means more than one independent variable. You might wonder why you would want to use more than one independent variable, and I think a lot of you, as you were kind of zeroing in on what you wanted to do for your projects, you probably considered the different effects of different types of variables. So maybe you were thinking about more than just, a positive portrayal of a particular group versus a negative portrayal. Maybe you were wondering if it had to do with, people's pre-existing attitudes about those groups or their mood when they encountered those manipulations or something like that. And I think it's really natural to think about how things influence each other in this way, because thinking about the world in terms of one variable affecting one outcome is really not very realistic. As scientists trying to get a high level of control and internal validity, we want to frequently have a lot of consistency and obviously a lot of control over what's going on. But that level of control, as we've talked about, is kind of artificial in some ways. But you can kind of maintain that level of control and introduce more explanatory power by introducing more independent variables. So one reason you might use more than one independent variable is just because life tends not to be as simple as one thing causing another. Usually, or I'd go so far as to say always, things have multiple causes or multiple sources. It's not just that you got a good grade on a paper because you were well rested, or that you performed well in a race because you practiced a lot. Like, there's a lot of other things that contribute to that, right? Or it's not just that you perceive someone's attractiveness at a particular level because of their hair color, right? There are lots of other things that go into that sort of judgment. And it's not to say that hair color doesn't matter for perceptions of attractiveness, but there are lots of other things going into that, like other physical characteristics, things about people's personality, their behaviors, their attitudes, their values, lots of different things go into attractiveness judgments. So we would often want to use more than one independent variable just to explain how complex life is, because usually things don't just have one sort of source. It also is the case very frequently that it's not that these independent variables we might choose, like, let's say we're sticking with like the physical attractiveness example. Maybe you think hair color matters and you also think height matters. That people with a particular hair color or a particular level of height are more attractive than others for some reason. It's probably more complicated, though, than just people having darker hair being more attractive or being taller being more attractive. Maybe those variables do something to one another. That, people are, let's just say, more attractive if they're taller and have only if they have blonde hair or something like that. That these variables interact in a way that is more complicated than their effects on their own. And I know that it's probably not the most clear example right now, but I'm going to go through some specific ones from a real study and some other hypotheticals just to kind of drive these things home. So the effects within a study are sometimes more than the sum of their parts. It's not just that independent variables have their own discrete effects on dependent variables, it's that they can influence one another too. So formally, an interaction is when the effect of one independent variable differs depending on the level of a second independent variable. So maybe, let's stick with my kind of silly attractiveness and height and hair color example. Maybe there's a main effect that people that are taller are more attractive, but that effect is only in existence for blonde people. Like, if you look at people of different heights that have dark hair, it doesn't matter how tall they are for their attractiveness judgments. But you find that short blonde people are just uniformly less attractive in people's perceptions than tall blonde people, right? So there's an interaction between height and hair color. The way that you test these sorts of things is by crossing these independent variables in what we've called factorial designs. We've talked about this a little bit before in terms of how designs that need ANOVA statistical tests work. I think it's come up a couple times before, but factorial designs just mean that you're crossing all levels of independent variables with all other levels of your independent variables. So just to make this a little less abstract too, I know that's kind of hard to think about if you don't have examples. I'll go through kind of the notation for how factorial designs work, and then I will show you kind of visually how you might think about them if that still doesn't quite make it clear. I think thinking about this stuff in a couple of different ways can be helpful. So factorial designs, the way that you would describe them in writing is by noting the number of variables and the number of levels. And the way you do that is that you, the number of numbers that you have basically is the number of variables that you have. And then the numbers actually indicate how many levels of an independent variable. And, I'm just going to start showing these because it's really difficult to describe that clearly just in saying the number of numbers. That's just kind of confusing. So the simplest factorial design that you could have, for example, is a 2 by 2 design. So think about each of these 2's as noting something about 2 different independent variables. Here's independent variable A. Here's independent variable B. Independent variable A has 2 levels, thus the 2 here. Independent variable B has 2 levels. So maybe let's say these are short and tall people, and light and dark hair. Your first variable noted here is height, and your second variable here is hair color. Okay, but maybe your design is more complicated than that. Maybe you think that, you know, height and hair color are both important, but there's something else, like let's say, you know, disposition, something about like a positive, neutral, or negative disposition in general. If you wanted to test that third variable, you could add independent variable C, disposition, and that in this case has 3 levels. So you still have independent variable A, short and tall, B, light or dark hair, and C, disposition, which has 3 levels, negative, neutral, and positive, right? So these things all get combined together so you can see how they interact with one another in addition to their own effects on a dependent variable, in this case, attractiveness. The way that you can tell how many discrete combinations of these that you have is just by multiplying these things together. So in this simple example here, where you have two two-level variables, when you cross those, it makes 4 different conditions. You have short people with light hair, short people with dark hair, tall people with light hair, and tall people with dark hair. They're just totally crossed with one another, with 2 independent variables of 2 conditions each, giving you these 4 conditions altogether. When you have a third variable, though, this adds more complexity. There's kind of exponential growth as you add more independent variables, particularly if they have more than 2 conditions. So if you did the other design that I described, where you add that disposition variable, then that quickly becomes a lot more complicated, where you have 12 total conditions. So it's basically this design, and you are combining each of these individual types of conditions with the disposition one. So 3 independent variables. If you have 2 conditions, and 3 conditions, then all told, you have 12 total unique conditions. So, you have short people with blonde hair with a positive disposition, short people with blonde hair with a neutral disposition, short people with blonde hair with a negative disposition, and all through these other 3 simpler conditions. So I know that is a little wordy, a little confusing. I encourage you to, ask me follow-up questions, because this stuff, even in person, when I'm describing this in class, it can sometimes be a little bit hard to follow. So I totally understand. Please let me know if you have any questions about that stuff. Maybe a slightly easier way to think about it, too, is by looking at it visually. Obviously, this is only really useful when you have a 2-variable design, because if you have 3 variables, then you either have to have 2 of these different panels, or you could kind of think about it 3-dimensionally, I guess, but that isn't super helpful when you're like writing an article or making a presentation about something. But I think, obviously, this just drives home how these things really are just totally crossed with one another. So maybe you think about variable A, sticking with the profoundly stupid example that I've stuck myself with here of attractiveness determined by these physical characteristics. You have short and tall people. Let's say A1 is short, A2 is tall. You have hair color. B1 is light, B2 is dark. So you have here A1 and B1, that's short hair and, short people and light hair, and so on, right? That you can see how each one of these independent variable conditions is crossed with another one. So 2 by 2 makes 4 of these unique conditions. So if you added in that, third variable of disposition, you can imagine 3 of these panels separately, adding in that, one of them you add in C1, and in the other panels you add in C2 and C3, making for 12 unique conditions where you're fully crossing all of those variables. Okay, I'm going to stop this video here just so it's not too long. I'm still going to try to break these up, but I'm going to talk about interactions a little more specifically when I start the next one.